All right. I had some questions come up about problems similar to this one in ALEKS, where you have to work with systems of equations. So I've come up with this one that I was sent that I'll walk you through, and then also I came up with a couple of other word problems that deal with systems of equations. Sometimes people get tripped up here because you're just trying to talk about two numbers and you don't have any more information. Sometimes you get tripped up in a situation like this because they talk about something being 3 times as large. Sometimes you just try to guess and check, and that doesn't work very well either. So I tried to come up with different problems that'll walk you through different scenarios of what to try. So starting with this one, a strategy I always tell people when you're working with word problems is to try to pick letters that stand for what you're talking about. But this is hard when you just are given two numbers. So if I were you, I would just probably call these two numbers like X and Y because I don't know anything more about them really. So the sum tells me that I'm going to add them. So x plus y, and I am supposed to get 52. And then they tell you that one number is 3 times as large as the other, but there's no like identifying information here about whether it's x or whether it's y, so it really doesn't matter how you do that. You could say that x equals 3y, or you could work this problem by saying y is equal to 3x. Really doesn't make a difference because they didn't specify which number that you were talking about. The next two problems I picked, it is going to matter which one you multiply by, and so I thought if that was your issue on this type of question, I would give you some examples where you would have to distinguish that as well. So now we have a system of equations because we have two variables that we're trying to solve for, and we have two equations that involve those variables. And my options at this point are substitution or elimination. Noticing that this one is already solved for x, I'm just going to take this 3y and I'm going to substitute it into the first equation whenever I see an x. So my first equation is going to turn into 3y and then plus y equals 52. So that means 4y is equal to 52. And then dividing both sides by 4, y is equal to 13. Well, if y is equal to 13, then I can come back up here to what x was equal to. So x is equal to 3 times 13, which is 39. So the two numbers are 13 and 39. And you can see that 39 is 3 times as large as 13, and you can add them together and double check that you get 52. But guessing and checking isn't a great strategy here. You might think, as far as how this is presented, oh, well, if they just made this multiple choice, then I can clearly just add up all the numbers, and then I can just check which numbers I can start with the smaller one, multiply by 3, and get the larger one, and that's what I'll pick. True if they made it multiple choice exactly how it's phrased here, but my thought is if it's a multiple choice question, they're probably not going to ask you to find both numbers. They're going to ask you to find the larger number or the smaller number to make it trickier for you, where they're not going to show you that 3 times as large relationship, and they're not going to show you that adding to 52 relationship. You're going to have to come up with it yourself. So just as kind of multiple choice strategy to have that on your radar, it's worthwhile for you to go through the solving process of this because I could make it a tricky multiple choice if I wanted to. Okay, next one. Matt and Scott are siblings. 5 years ago, Matt was twice as old as Scott. Today, the sum of their ages is 25. How old is Matt today? So this is already kind of going to what I just talked about as far as multiple choice strategy. I could just ask you about the age of one person, and then that's really easy to make trick answers by giving you the age of the other person as well. And it's a trickier question because you can't check what their ages add to if I don't give you both ages in the multiple choice. This one will allow you to do the strategy of what I was talking about. So it talks about Matt and Scott. So we're going to use M for Matt's age today. And we're going to use S for Scott's age today. Then it talks to us about 5 years ago. So that would be Matt minus 5 and Scott minus 5. Or M minus 5, sorry, for Matt's age today, minus 5, and S minus 5 for Scott's age today, minus 5. So 5 years ago, Matt was twice as old as Scott. So M minus 5, that was Matt's age. It was, so equal to, twice as old as Scott. So you need to take Scott and double it. So 2 times Scott then, and Scott then is S minus 5. Matt is the older one. Sometimes people misunderstand this twice piece. They don't know where to put it. And so when they see Matt was twice, they'll put 2 times Matt. If you really think it through, it should make sense. Matt is the older one. He's twice as old. So you need to go to the other one, in this case, Scott, but in this case Scott minus 5, and you need to double that one to get up to build up to Matt's age 5 years ago. Okay, so this is one of our equations in our system, and you know that it needs to be a system because you see that you have 2 letters. Well, you're not going to be able to solve for each of those letters unless you have a second equation. 2 letters requires 2 equations. 3 letters would require 3 equations, and so on. Okay, today the sum of their ages is 25. Well, so since I see this today part, I can use the M and the S because I used their ages today for that lettering system. So the sum of their ages is 25. So M plus S equals 25. And that's our second equation. Now, again, I talked with you in the last problem that you could solve this with substitution or elimination. Those are your strategies for systems of equations by hand. I know in ALEKS it references matrices, and you could use matrices. They're a great tactic to use solving real life problems, but you are limited to a very basic calculator on the DAT, and so with that, matrices by hand are not a time savings. So we're going to stick to just substitution or elimination. Now, our last question was set up really, really well to do substitution because we had it in an x equals format. So we could take what x equaled and just substitute it up into the other problem. I don't have that here. I don't know what m equals. I don't know what s equals. Now, if I want to get that, I could say m is equal to 25 minus s, and then I could take this 25 minus s and substitute it in up here. That would be an option. If you ever end up with a question where you had like 2m plus 3s equals 25, then that's a real pain to solve for one of the letters, and so I would never do substitution in that scenario. But in this problem, I mean, substitution is a possibility. You can go for it if you like. It's not super nice. The problem's not really super nice no matter how we go, but since I haven't done an elimination with you, I'm going to show you how to do this one with elimination. So I'm just going to make a note that this is how to do it with substitution. And you could finish that one out and verify that you get the same result, and then just contact me if you have any issues and I could work it out that way for you. But I again want to show you an option of doing it with elimination. So if we do elimination instead, you need to get the equations in the same format. So I need to work with equation 1 to line it up in a format that's similar to equation 2. So I'm going to distribute m minus 5 equals 2s minus 10. And then notice the order of this. I had m plus s equals my number. So I'm going to keep the m on the left side. I'm going to add the 5 to both sides so that I can get rid of the number and move it to the right side. And then I'm going to subtract 2s on both sides so that my first equation becomes m minus 2s is equal to negative 5. Now that's in the same format as my second equation. So equation 1 in this format, m minus 2s is equal to negative 5. And then equation 2 as is, m plus s is equal to 25. And now how elimination works is you line up your letters, you line up your numbers, and then you want to get it where when you add the two equations, one of the letters is going to cancel. Sometimes to do that you would have to multiply. So like if you notice, some people will pick up on, oh, well, I have a plus and minus already, I'm just going to work with that. Well, then you would need a 2 to go with this s, so you would have to balance the equation and multiply 2 by m and multiply 2 by 25 so that you kept your equation balanced throughout. And that would work, and then you could add them up. I tend to go with noticing that my coefficients already matched right here. These were each a 1. So then if I just take and make one of them negative, then when I add them up, they cancel. So that would tend to be my go-to on a question like this. So how you would make that work is you need one of them to be negative and it doesn't matter which one. I tend to work with the simpler equation, so multiply by a negative on the bottom to all of the pieces. And then add these up. Well, so the m's cancel. Negative 2s minus s is negative 3s, and negative 5 minus 25 is negative 30. And then divide both sides by negative 3, so you get 10. A lot of times people are weirded out by negatives on word problems, but notice I had a negative on both sides. It ends up canceling out. I will tell you sometimes students have a wrong solution, and so they maybe got a positive 30 instead. And then they come up with s equaling negative 10, and they go, oh, well, that's a word problem, it can't be negative, and they just drop it off and move on. That's never, ever, ever going to be a correct methodology to solve. If you need to just drop off a negative, you did something wrong in your process, and you need to go check it. But just because you see a negative in your work doesn't mean that it's wrong, because if you follow it all the way to the end and there's a double negative and it ends up canceling out and turning positive, then you're okay. All right, so we know that S is 10. So that, if you go back up to what you started with, that is Scott's age today. Scott's age today is 10, but they want to know how old Matt is today. So then we can go back to any equation that we already have and figure out Matt's age. I'm going to use the second one here, that Matt plus Scott was 25. So if I have that M plus S is 25, then I can change that to M plus 10 is 25. So then I can solve and get that m is 15. So today, Scott is 10, Matt is 15. And that then means that 5 years ago, if you want to check, 5 years ago, Scott would be 5 then, and Matt would have been 10, and you can see that Matt was double his age. And you can see that at their present ages, if you add 10 and 15, you get 25. So that's a nice check. But going back to the question, they wanted to know Matt's age today, and so Matt's age today is 15 years old. Okay? All right, again, if you chose to work this with substitution, you would have solved for Matt here, plugged in, found Scott's age, and again gone back to solve for Matt's age. You should have come up with the same two numbers that we had. Or you could have, from right here, said that Scott is 25 minus Matt, and then you could have taken this part and put it here. You just need to pick one of those options. It's not going to make a difference which one. It's actually going to be less work for you if you would solve for Scott in the number 2 and then plug it into the number 1. But that's just based on this problem. So in general, it doesn't matter which one you solve for. Okay, one more word problem, working with systems. You need 50 feet of fencing to enclose a rectangular area whose length is 5 less than half the width. That's a lot going on there. This is one that I would encourage you to draw a picture. So in the CE webinar part, it's under the pictorial representations, and I would label L and W around my fence. And so if I need 50 feet of fencing, I would enclose 2L plus 2W, that's the perimeter piece, would be 50, because I would have to enclose all the 4 sides I just drew out. Well, that was 2 of the L's and 2 of the W's. Now, this next part. The length is, so L equals 5 less than, that means I want to take away 5 at the end, half the width, 1/2 W. Length is, so L equals, 5 less than means when you're all done you're going to take off 5, half the width, so 1/2 W. Okay, well this one is set up really, really well for substitution, just like our very first one, because we had x equals on its own. Well, in this case, we have L equals on its own. So I'm going to take this entire piece here, and instead of L in my top equation, I'm going to substitute that in. So my new top equation is 2 times the quantity, I'm gonna just pick a new color, go with that color, 1/2 W minus 5, and then plus 2W is equal to 50. I do want to draw your attention to something. If you notice that in the top equation everything's divisible by 2, you could get an equivalent equation of L plus W equals 25 if you want. However, on this particular one, distribute, the 2 times the half cancels really nicely. I'm going to leave that there. A lot of times I would go up and simplify it because you can get rid of all those 2's and you have smaller numbers. But in this sense, the 2 and the half cancel, so I get rid of fractions. I would rather, on a test where I have such a basic calculator, I would rather not have to deal with fractions. So I'm going to leave it this way and distribute. So 2 times 1/2 is 1, so 1W, and then don't forget to distribute to the -5 as well, minus 10 plus 2W equals 50. So 3W, combining like terms on the left, minus 10 equals 50. Add 10 to both sides. 3W is 60, divide both sides by 3, W is 20. Now let's make sure that we answered the question. Find the length of the rectangular area. So now I need to go back to this part about length. So length is 1/2 W minus 5. Length is 1/2 times W minus 5, and I know W now. And then if I clean that up, 1/2 of 20 is 10. 10 minus 5 is 5. They wanted the length is 5 feet. Now you might say on a question like this, well, wait a second though. What if I want to draw my rectangle and I want to call this side L and I want to call this side W? And so in that case, you would come out with, like we came out with, the longer side. Actually, we did come out with it that way. The longer side was the width, which was 20. And the shorter side was the length, which was 5. And you might say, okay, but I started, like, wait a second, you started drawing us a picture where the length was the longer side. Yeah, true statement, but how you keep all of that straight is by how they describe the problem to you. Notice that they said the length is, so that's your key to set up your formulas, and then the rest just takes care of itself. I just drew a different rectangular representation than how it ended up working out. Your image that you start with isn't always to scale because you don't know all the information starting out. So don't fall in the trap of thinking that length is always your longer side. It's not necessarily. Okay? All right, so there are 3 examples of systems of equations. Again, in ALEKS, it will talk about matrices as well, but that's not a DAT tested topic. And given the fact you have a really basic calculator, I'm not going to encourage you to use matrices at all. But if you do have any more questions on substitution or elimination, please let me know. I'm happy to work some more examples for you, or I'm happy to go back to these examples and re-explain some things for you. Also, I tried to do a good job of highlighting when to use substitution, when to use elimination, and picking some questions about like half of and 3 times, things like that. Okay? Thanks for your time.